Hello all, today I have a very interesting video on various experiments, different activities and real life examples on Bernoulli's principle. Before we deep dive on the experiments and the examples, just few lines you must remember on Bernoulli's equation, which is simple but incredibly important to understand the behavior of fluids. In a simple form, it is a statement of conservation of energy, and Bernoulli's equations state that the pressure of a fluid is inversely proportional to its velocity. Suppose if there is a fast moving air, then its pressure reduces. With this in mind, let us see some experiments. This is a small setup I have made to explain Bernoulli's principle. The bottle's top half has been cut and through the cap a small hole I have inserted a straw. This is a simple ping pong ball. If I hold the ball vertically, of course it will fall due to gravity. But see what happens when I blow hard in this straw. See once again. You see, I am able to hold the ball. So how is it possible? Let me explain this. When I was blowing air hard through the straw, the fast moving air created a low pressure around the ping pong ball. The slow moving air below the ball is at the higher pressure. This pressure difference could hold the ball as long as I was blowing air through the straw. This is a very simple setup to explain Bernoulli's principle. I have filled this glass with plain water and inserted a straw. See what happens when I blow hard at the top of this white straw. You see the spray of water coming out? See again. This is happening because of Bernoulli's principle. How? Let me explain. In this activity, I used two straws. You must have noticed when I blew hard through one of the straws whose end is just above the other straw dipped in water, then the fast flow of air moving out created a low pressure at the junction point of the two straws. There is a higher pressure below. This difference of pressure resulted in a sucking of water from the glass in the straw which was dipped in the water. On the same principle, the paint gun or the spray gun used to paint works. The paint is put in the jar which is at the atmospheric pressure. There is a fast jet of air flowing right over the end of the pickup tube that sucks the liquid up the tube and it comes out as a spray paint. In this setup, I have two thermocol balls hanging freely through a thread. If I blow air in between the balls, what do you expect? Will they move apart or will they come close? Let's see. You see it is coming closer. Let's watch once again. Do you know why it is happening so? Bernoulli principle explains this phenomena. Let's see how. When I am blowing air between the thermocol balls, the fast moving air created a low pressure between the balls. The pressure on the other sides of the balls are higher. This difference of pressure made the ball come closer. This is another simple way to understand Bernoulli's principle. Make a cone out of a newspaper. Tape the end and pass a pipe to blow the air. I have used the back of the ballpoint pen to pass the air. What will happen if I blow air through this pipe? Will the paper will come together or will they move apart? Let's see. Well, they are coming together. Let's watch once again. Why it is happening so? Bernoulli's principle explains this phenomena. Let's see how. When I am blowing the air hard inside the cone, the fast moving air created a low pressure inside the cone, while the pressure outside the cone is higher, which compressed the paper cone. Let's see some more experiments on Bernoulli's principle using a hair dryer and various balls. Let's observe them closely and then we will understand the theory behind it. Let us now try a thermocol ball, which will be a little lighter than this ping pong ball. Let's see what happens. So, what makes the ball float in the air? The air at the high velocity blown through the tube created a low pressure zone, forcing the ball upwards. The lighter the ball, more higher it goes. Observe it once again. You saw when even when I bent this tube, the ball was not falling. Tilting the blower or the tube is not making the ball to fall as it wants to stay in a low pressure zone. Or in other words, the air around it is at higher pressure, which pushes the ball back to the lower pressure zone. Let's observe what happens if I have two identical balls. You saw they were fighting to occupy the same position. Have you ever observed the shape of an aeroplane's wing? It also uses Bernoulli's principle. It is curved from the above and flat at the bottom. Curved from the above means the air has to travel faster. Faster traveling air means the low pressure is developed above the wings and there is a high pressure of air below the wings, giving it a lift, and hence aeroplane is able to take off. Let me explain this with diagrams and figures. The shape of an aeroplane wings look like this. The upper surface is curved and the lower surface is flat. This is intentional, keeping Bernoulli's principle in mind. As the aeroplane wing slices through the column of air, the air going over the top of the wing has to make the longer path than the air below. Because air is elastic and they will meet on the other side, to do so, the air going over the top has to move faster to cover the larger distance. And as the Bernoulli's principle state that the air moving faster will have a lower pressure, there is a lower pressure created above the wing which sucks the plane in the air. The same principle helped the birds with their aerofoil shape to lift themselves and are able to fly. The Bernoulli's principle also explained the blowing of roofs during storm. When high winds blow over the roof, it creates a low pressure over the top. The pressure below the roof is high. The difference of pressure causes the upward thrust and the roof is lifted up and it's blown away with the wind. We are always advised not to go near the fast moving train, as the person near the track of fast moving train has a tendency to fall towards it because the air between the person and the fast moving train with high velocity has a low pressure and the air behind the person has a higher pressure which pushes him towards the train. You know, Sarfraz Nawaz introduced reverse swing bowling into international cricket in 1970 and passed on the knowledge to Wasim Akram and Waqar Younis. Probably Sarfraz could really understand well the Bernoulli's principle than anybody else. To achieve reverse swing, the players try their best to retain shine on one side of the ball by rubbing it on their thighs repeatedly. Naturally, as the ball gets older, the other side of the leather ball becomes rougher due to wear and tear. Then the ball starts reverse swinging. The delivery comes into the right hander if the smooth side of the ball is facing towards him, and the ball swing away from him if the shiny side of the ball is not towards him. So if the bowler is bowling an outswinger with the usual seam straight position, the reverse swing make it as an inswinger and vice versa. If we apply Bernoulli's principle, the air on the shiny side of the ball will travel faster and hence low pressure compared to the rough side, which makes the ball move towards the shiny side. Hope you enjoyed watching the experiments and the real life examples on Bernoulli's principle. I really enjoyed sharing it with you. Bye bye for now.